So speaking of math, sorry, I apologize. I know you did not sign up for a math class, so this is kind of a dirty trick, but we're going to do a little bit of math today. Not anything advanced. We're not going to do calculus or any of those other things. I think I told you at the beginning of this class that my intimidation with some of the higher level math is why I didn't end up pursuing computer science, which was actually a mistake because math is kind of fun now that I don't know, maybe now that I don't have to do it in high school math class. Um, but today we're going to do some really basic math, and I'm going to introduce you to what are called operators. Operators are not who you ask for when you're on tech support for Verizon for 30 minutes. Operators are, not that that would ever happen because Verizon's great. Operators are things that we use to create what are called expressions. And an expression involves any more than one value, like a variable or a number or a whatever, plus at least one operator. So we'll get into expressions in a minute, but let's talk about operators and what they mean. The first one we've been using already, and this is technically an operator, and it's technically an expression. X equals 3 is an expression because it has at least one operator and two values. Or x equals 3, sorry. X equals 3 is an expression. Assignment means we are telling X that it is going to contain the value 3. X is equal to 3 at this point. So X is 3, right? That's an easy one. I'm going to really ease us into this, you guys. Really easy. Okay, so if we have the addition operator, this is again an expression. It has two operators and three values. In this expression, what is X equal to? 4. So you guys are good at math. All it takes is a little bit of confidence. We have the subtraction operator. So far, I shouldn't be showing you anything new. What is X equal to here? 2. Now, how many of you have seen this symbol used as multiplication? Okay, it's becoming more common, thank you. It's becoming more common, but we can't use X for multiplication because X is a character that we use for other things like naming variables or whatever. So in programming, we can't use X and we can't use the dot, which is also often used for multiplication because the dot is used for other things too. So we use the asterisk, okay? The asterisk is used for multiplication. So in this case, in this expression, what is X equal to? 6. How many of you have been sitting here doing that math the whole time I was talking? Just kidding. All right, so it's 6. Okay, so we also have division. Now, I know that division, we've used the percent sign, we've used, sometimes they're stacked like a fraction, but since we have to express things in programming in a linear way on a single line of text, this is what we use for division. Trick question, or tricky question, not a trick question. It's really basic. There is only one answer. Is that a forward slash or a backslash? Good job, everybody. Yeah, that's a forward slash. A lot of people are gonna say backslash if I ask them to read these characters out, they would say backslash. You know, it's a forward slash because it's leaning forward in the direction that you read. So if it's leaning in the direction that you read, which is left to right in English language, then it's a forward slash. Backslash means something else. That's why I'm making a big deal of this. So there is a difference in meaning. Forward slash is division. Backslash is something else that's not division.
What if you do put a backslash?
If you do put a backslash, it depends on what's on either side of it, but it'll probably give an error most of the time. Yeah, because it's used for escaping things in strings, which doesn't mean anything to you now, but it will at some point. So that's division. So far, so good. We feel pretty comfortable with these, the basic math operations, good. So there's one more that's a little bit, now we're getting a little bit out of maybe our comfort zone, right? So this is an exponent, and you would read this 2 to the power of 4, which means 2 times 2 times 2 times 2, right? So x is equal to what? 16. 16. All right, so those are the easy ones. Now we're going to get into the better operators, the more exciting operators. I love modulus. I drastically underestimated the usefulness of modulus when I started programming. I thought, why would you ever want to know that? And as it turns out, the answer is you will want to know that all the time. What modulus does is it takes the first number and it divides it by the second number. But what it gives you in response to that is not the answer to the division problem. What it gives you is the remainder after you do the division. So 10 divided by 3 is 3 point something, right? 3.333, whatever. So 10 divided by 3 is 3 point something. But what's the remainder? If I do that division problem, what's the remainder? 1. So it's 3 with a remainder of 1. The 3 just goes away. All this returns to you is 1. So in this case, x equals 1. Very useful for lots and lots. Trust me on that. You'll use it. Floor division. Okay, floor division is basically the equivalent of doing the division and then converting it to an int. Because whatever's left past the decimal just goes away. So 10 floor divided by 3 is what? 3. It's just 3. The nice thing about floor division is that it returns an int. Any other division problem, even 3 divided by 1, will return a float. Just something to keep in mind. So if you need an integer as a result of this, and you're willing to sacrifice a little bit of precision in terms of getting rid of a decimal, you use floor division. And then you don't have to convert it to an int because it returns an int to you. So 10 divided by 3 is 3. Now, if you notice, these two things kind of go together. Because if I do this and this, now I have the result and the remainder. Okay? So those go together. The increment operator is a brilliant shortcut, and it lives in a lot of programming languages. But the increment operator says, take whatever's in here and add this to it. Don't take it out. Just put the extra 3 in that bucket with whatever's in there. It doesn't care what's in there, unless this is a string or a data type that you can't add to. Then it's going to give you an error. But if this is a numeric data type, it's just going to take 3 and add to it. So if x started out as 1, and I do this, what is x equal to now? 4, because I'm adding 4 to it. When I say plus equals 3, I'm taking this, if it starts out as 1, and adding this to it, which makes it 4. Okay? And I have increment operators for every single major operation, including subtraction, division, multiplication, exponentiation, and floor division. There's one missing here, and it's modulus. There is no increment operator for modulus because doing the division and incrementing it by the remainder doesn't make sense logically. There's no reason you would want to or need to do that. So, but there is floor division, which is nice. So any of those symbols with an equal sign after it is the increment operators. One more thing before we leave math land here, and that is order of operations. Now, there's a clever, actually it's kind of stupid, acronym that they teach you in math, right? Anybody know the acronym that they teach you to remember order of operations? PIMDAS. Does that make any sense to anybody, that word? I mean, outside of what we know it stands for, like that's not an easy word to remember, right? I'm not aware of any significance in the English language. But yeah, PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction, and always left to right. Why does that matter? Why does it help us? Because if I have a formula that looks like this, yes?
I was going to say there's a new one that they're teaching, maybe they're familiar with, GEMS.
I haven't.
GEMS is groupings, exponents, multiply, divide, and subtract that. GEMS.
Groupings, exponents, multiply and divide. So the D is just included with the M, multiply, divide, and what's the S? Subtract and add. I think they're switching things around on me. I think they're just picking letters that sound cool. But GEMS is better than, I think, yeah, probably GEMS makes more sense than PEMDAS, which is a low bar, right? So GEMS, PEMDAS, maybe I'll throw GEMS in there on for my next class so I can look like I'm contemporary. So if we solve this, we would use these rules to decide which order to do things in because it matters what order you do them in. If you do them out of order, out of the correct order, you'll get all kinds of different answers. So we need to know the correct order of operations so that when we're putting formulas together, and sometimes formulas like this can feel a little bit confusing to put together in a linear fashion. You're going to find out here in a little bit. If you don't know the order of operations that Python is going to use to solve that equation, then you won't know what order to put them in, if that makes sense. So, and one of the big things that you can use, it's almost like a get out of jail free card, is parentheses. Using parentheses to group things to make sure that those things get done first is really useful. For example, if I wanted to make sure that 5 was multiplied by 2 before it was used as a power of 4, all I do is throw an extra parentheses in there. That would be 2 there. But now I force that to happen first. So you can, even though normally it would be 4 to the power of 5, now it's going to be 4 to the power of 10 because I forced that to happen first using parentheses. So parentheses is kind of like secret sauce when it comes to putting formulas in. And as long as you have a matching end parenthesis to a matching opening parenthesis every time, you're going to be okay. You're not going to have errors. But you need to pay attention to the parentheses and what they're surrounding. So how would this problem be worked out using PEMDAS, right? I'm going to start with parentheses. And inside those parentheses, right, I'm going to take this set of parentheses and just work that out. 2 plus 3 is 5. The parentheses go away. Inside this set of parentheses, I've got a little bit more complexity going on. So I'm looking inside this parentheses, and I say, oh, the next thing is exponents. So inside this parentheses, I do the exponent 4 to the power of 5, which comes out to 1024. The next thing, multiplication. So this gets multiplied times 2, right? To 2051. So I multiplied this times 2 and added 3 is what happened there. So this is 2048. Then I add 3, so I've completed that parentheses and it goes away. This 5 plus 4 times 2051 plus 30 divided by 6. So now I'm back, the parentheses are gone. Do I have any more exponents? No. I look at multiplication and division going left to right. So going left to right, first thing I encounter is 4 times 2051, and then I have 30 divided by 6 right here. So now I've completed all the multiplication and division, and then I just need to add those together. And the answer to that equation is 8,214. You're like, oh God, that's a lot of math. Only a few times in my programming career have I actually had to put a formula into Python that was that complex. Only a few times where I actually have used that level of complexity. That's not actually that bad if you sit down and work it out and you take your time. But most of the time, the formulas you will use are fairly simple. Now, If you get easily overwhelmed by something that looks like this, another thing you can do other than parentheses is you can break it apart into multiple steps. Now imagine if I took everything inside here, just these four things, 3 plus 4 to the power of 5 times 2. I could take that, take it out, and put it on a separate line and make it equal to a variable. And then I can just take that variable and put it right here instead. So you can break things down into multiple steps where you're solving pieces of the equation, assigning the results to a variable, and then you can put it all together in a final step where you combine the variables. Now, what I just said, those last 3 or 4 sentences, may not have made absolute sense to you. I can tell by the look on some of your faces that it didn't really come through clearly. However, when you start building assignment 4, where you'll be using formulas to come up with a value, it might make more sense.